Dr. Vijay Lakshmi is working as a professor in the Department of ECE, Anna University, Chennai. She has more than 17 years of experience in teaching. She has published more than 90 papers in international and national journals and conferences. She has organized more than 10 workshops and has attended more than 40 workshops and seminars. She has guided more than 100 projects in both UG and PG level. She is supervising 14 research scholars. She has established an AICTE sponsored MODROB project for VLSI lab. She has an endowment award for the top rank holder in PG degree and has 4 cash awards for producing cent percentage of result in Anna University curriculum. She is a life member in various professional bodies like ISTE and IETE. She has specialized in mobile communication, microprocessor and microcontroller, digital system, computer networking, and neural networks.
Welcome to UGC lecture series BSc Electronics, Electronics Practical 9. In today's session, we will discuss about instructions of 8085. Instruction, it is a predefined binary pattern to complete the specified task. In the microprocessor, it have a two formats, opcode and operand, which is followed in the entire instructions. In 8085, it has 246 instructions. The instructions are classified based on its operations, which are data transfer instructions, arithmetic instructions, logical instructions, branching instructions and machine control instructions. So, based on the name, I think you can guess what will happen. In the data transfer instruction, it is mainly used for transfer the data between the registers or between memory and register, or you can initialize the data or you can store the data. So, this kind of operations will performed in the data transfer instructions. In arithmetic instructions, you can perform addition and subtraction. Only addition and subtraction will be performed in 8085. Along with that, the increment and decrement instructions also available. If you want to increase the counter value, you can increase it or you can decrease it. The logical operations, which consists of the basic logic gates, which are AND, OR and NOT. Along with that, exclusive OR. Then shift and rotate operations also possible in 8085. In branching instructions, it will branch, that is switch over from the main program to the subprogram or from the current location to the new location. The how it will switch over based on the flag register, or in the flag register it will check whether the condition is meet or not. When it will check the condition, then switch over to the specified location, that is called as conditional branching instruction. Without checking the flag, it simply switch over to the specified location, then it will call it as a unconditional branching instructions. The last one is machine control instructions, which will control the machine operation. To reset or to clear the registers, we can follow the machine control instructions. Now, we will discuss each instruction with corresponding format. The mnemonic format is very important to write the program. So, the first we will discuss data transfer instructions. This transfer instruction, which is used to transfer the data between the register or between memory and register, or we can load the data to the source into the register, that is either we can store the data or we can load the data. For that we have two kind of instructions, load and store. So, before entering into that, we have to recollect what are the registers in 8085. What are the general purpose registers? It has 8 bit register as 6 numbers, that is B register, C register, D register, E register, H and L register, along with that special register accumulator. So, based on this register only we are planning to write the program. The data transferred between the registers means only within these registers you can transfer the data, or you can initialize any value into the register. See, this is a general format, the data transfer instruction, which is used to transfer the data from source to destination. So, the first instruction format is between the register, source register to destination register. Suppose the register if you are giving B and C, then C is a source register, B is a destination register. So, after executing this instruction, whatever the content in C will be moved to B register. This instruction copies the contents of the source register to the destination register. The contents of the source register are not altered, only the destination register will be copied. The another instruction is move M comma RS. So, any one of the source register content will be stored in the M register. M register is a memory register. For that we usually storing the HL register pair. The another instruction format is MVI. In MVI, which is mainly used to load the 8-bit data, the data can be either into the register or memory, we can initialize it. So, MVI B comma 45H or MVI B comma 57H, it represents the data 57 is loaded into the B register. Next one MVI M comma 57. So, the 57 is loaded into the memory which is specified in the HL register pair. The another instruction is LDA. LDA is load accumulator. So, how to load the data into the accumulator via the memory access. So, the content of the memory location specified by the 16-bit address in the operand are copied into the accumulator. So, whatever you are specifying the address in the address field, that content will be loaded into the accumulator. Here the source content is not altered, the address also having the same data. Example LDA 2034. So, the content suppose 40 is stored in that 2034. After executing this instruction, the content of 2034 which is 40 is moved to the accumulator, because accumulator is a 8-bit register. Another one is LDAX register pair. This is a indirect addressing. Based on that, the address is specified in the register pair, that content is moved to the accumulator. The content of the designated register pair pointed to the memory location. This instruction copies the content of that memory location into the accumulator. The contents of either the register pair or the memory location is not altered. This example is LDAX B, or you can use D register pair. Only B and D register pair can be used as in the LDAX, parallelly in the SDAX instruction. Next one is LXI register pair comma 16-bit data, which is used to initialize the 16-bit data into the register pair. The register pair may be BC register pair, HL register pair and DE register pair. LXI H comma 1 2 3 4, it is divided as 2 bytes, 1 2 as higher byte, 3 4 is a lower byte. So, the 3 4 is loaded in the L register, 1 2 is loaded in the H register. The HL also 2 registers, right. So, the lower byte is loaded in the lower register, higher byte is loaded in the higher register. So, in this example LXI H comma 20 34, right. So, the 34 is loaded in L register, 20 is loaded in H register. The another instruction is LHLD 16-bit address, which is represents the instruction copies the content of the memory location pointed out by the 16-bit address into the L register. The next memory location 16-bit address plus 1 will be loaded into the H register. In example LHLD 2040H. So, 2040 the content may be 20 is loaded into the L register, 2041 content may be 20 is loaded into the H register. So, during the execution of this instruction, 2 address will be executed. This is store instruction STA 16-bit address, store the accumulator content into the specified location. The contents of the accumulator are copied into the memory location specified by the operand. Example STA 2500. If suppose I have the accumulator value was 25, the 25 is loaded into the 2500 memory location. It will comes under the permanent memory. STAX register pair, this is used to the content into the memory location is specified in the register pair. The content of the accumulator are copied into the memory location specified by the contents of the register pair. STAX B, BC register pair is used to hold the location 4500, then the accumulator value is 20, then the 20 is loaded into the 4500 by using this SGAX B instruction. In SGAX and LDAX you have to use only BC and DE register pair, HL you could not use it. SHLD 16-bit address is similar to the load instruction. The content of the L register are stored into the memory location specified by the 16-bit address. The content of the HL register are stored into the next memory location. Example SHLD 2550H. While executing that, the L content will be loaded into 2550H. After that, the address will be increased 2551. Now, the H higher value will be loaded in the higher address. Exchange instruction, this is used for the 16-bit register pair. Automatically it will swap the content from DE register pair to HL register pair. While writing the program, if you did not have any sufficient register, automatically by using that the resultant value automatically interchanged. After executing, both register value will be interchanged. This is one of the special instruction, out port address. Out port addresses, the port address should be 8-bit. This instruction used to interface the microprocessor with the external device. So, it indicates the accumulator content will be transferred to the specified port address out 78. The instruction format is out 78. The 78 represents the port address. The accumulator content will be transferred to the 78 address. And already we have discussed, it may be either peripheral related instructions or memory related. When peripheral device, we have to use only in and out instructions. The next one is in 8-bit port address. It will copy the port address content into the accumulator. The port address should be 8-bit address. It may be varied from 00 to FFH, any number you can assign it. In example, in 8C. So, it represents whatever the content in 8C, it will move to the 8-bit accumulator register. This instruction is used to access the data from external device. Next, we will discuss about the arithmetic instructions. In arithmetic, mainly we are following addition, subtraction, increment and decrement. For the addition and subtraction, we have a two operand, right. One of the data should be loaded into the accumulator, another data may be with another register or memory, or it may be immediate data, right. Either the register or memory or the immediate data content will be added with the accumulator, then the result is stored in the accumulator. This is a concept in 8085. The result is stored only in the accumulator. So, addition we can perform with carry or without carry. So, based on that we have a two kind of instruction format. Any 8-bit number or the content of register or the content of memory location can be added to the content of accumulator. The result is stored in the accumulator. No two 8-bit registers can be added directly. So, with the help of accumulator only we can use it, that is add B comma C, it is not possible. This is the instruction format for addition, add register. It represents in the register is a 8-bit register, you can use any B, C, D, E, H and L, right. The general purpose registers, any register you can use it. Suppose if you are using add B means the B register content will be added with the accumulator register content, two 8 bits are added, now the result is changed in the accumulator. So, before execution the accumulator having one of the data, after executing now it has the only the resultant data, the B register content does not change. The same thing will be performed with the memory, add M. Add M means the memory content will be added with the accumulator, the result is stored in the accumulator. The next format is ADC, which is addition with carry. Addition with carry can perform with register or memory, which represents if the carry flag is set, then automatically the counter value will be increased by 1. What will happen? The register added with the accumulator, then plus carry bit, then the resultant stored in the accumulator. That is the difference between the add C and that is add CB, ADDB. ADDB is A plus B stored in A. ADCB means A plus B plus carry is stored in the accumulator. Suppose you did not have enough register, then you can load the data directly by using this instruction format ADI data. The given immediate data directly added with the accumulator, as result is stored in the accumulator. Example ADI 45H. The 45 data is added with the previously loaded accumulator value, then result is stored in the same accumulator register. The same direct addition also possible with the carry ACI. The mnemonic is ACI 8-bit data. So, the given 8-bit data is added with accumulator along with that carry bit. If carry bit is set means it increased by 1, otherwise plus 0 will be performed, then the result is stored in the accumulator. Example ACI 45. So, 45 plus accumulator content plus carry flag. The next one important instruction is DAD register pair. DAD register pair, which will used for the 16-bit register. The 16-bit content of the register pair are added to the content of HL register pair. The result is stored in HL register pair. If the result is larger than 16-bit, then automatically the carry bit is set. No flags are changed. Example DAD B, which represents the BC register pair is added with HL register pair. The result is stored in the HL register pair. Here how the 16-bit addition is performed is H and L, B and C both are added. So, after adding L and C, the result is stored in L register. After adding H and B, the result is stored in the HL register. This is the example of this. Okay. This is called as a lower byte, this is called as higher byte. The lower byte data of 2 register pair is added, the result is stored in L register. The higher byte data of 2 register pair is added and the result is stored in the L register. Next we will discuss about the subtraction. Subtraction format is SUB OR. So, either with the register or memory, the content is subtracted from the accumulator and the result is stored in the accumulator. If the operand is memory location, its address is specified in the HL register pair. All flags are modified to reflect the result of the subtraction, whether it is negative number or 0. Example sub A. Sub A means what it represents, the B register value is subtracted from the accumulator, then the result is stored in the accumulator. In case of sub M, the memory content will be subtracted from the accumulator and the result is stored in the accumulator. What is M means, the HL register pair content is called as a M register. Next one is subtraction with borrow. Subtraction with borrow also performed with either register or memory. Here what will the content of the register or memory location and borrow flag. Borrow flag is nothing but carry flag, or subtracted from the content of the accumulator. The result is stored in the accumulator. If the operand is memory location, its address is specified by the HL register pair. All flags are modified to reflect the results of the subtraction. Sub with borrow B. So, how it will subtract means accumulator content minus B register content minus the carry flag content, then the result is stored in the accumulator. In the previous case only A minus B, now the carry flag. If the carry flag is 1 means here subtraction, the resultant value is subtracted by 1, otherwise it is 0. In case of M, the accumulator value, M is reduced from accumulator, then if carry is set, the corresponding value. Finally, the result is stored in the accumulator. The another one is SUI 8-bit data. The 8-bit data is subtracted from the content of the accumulator, the result is stored in the accumulator, the flags are affected based on the result. See, SUI 45 means the accumulator value was subtracted from 45, then is stored in the accumulator. Suppose accumulator value was 78, then now the immediate data is 45. So, subtracted, so 3 and 3, now the resultant value is 33. So, this is a way how the instruction will execute. Another one is sub with borrow, immediate data, SBI. Immediate for borrow the given data. The 8-bit data and the borrow flag is subtracted from the content of the accumulator. The result is stored in the accumulator. So, flags are modified based on the resultant value. SBI 45. So, what will happen? The accumulator value reduced with 45, then carry flag. If the carry flag is set, means consider A equal to 79, then the immediate data is 45, subtract the value, it is 4, 3. If carry flag is set, then we have to again reduced by 1, which is 33 answer. The carry flag set represents the previous number, while doing subtraction it will get the borrow. The another instruction format is INR. INR, which is used to increase the register value by 1. The content of the register or memory location are increased by 1, the result is stored in the same register. If the operand is memory location, its address is specified by the content of HL register pair. So, INR B, it represents the B register value is increased by 1 and the result is stored in the B register. So, after executing, this is a notation B plus 1. Suppose B is 30, after executing, now the new value become 31. Either you can increase the register value or you can increase the memory content also by using the INR M instruction. Next one is INX register pair. Register pair value is increased by 1. The content of the register pair increased by 1, the result is stored in the same place. INX H, INR is 8-bit, INX H is 16-bit. This H represents, it is not a 8-bit data, it is a 16-bit data, HL register pair value, which is if you are taking 4500. Okay. This 00 is loaded in L register, 45 is loaded in the H register. After executing this instruction, this value is increased by 1. So, it becomes 4501. So, now the 01 is L register, 45 in H register. So, the new value was 4501. And the next instruction is DCR. DCR register or memory, which represents the decrement the register value or memory value by 1. Then the result is stored in the same register. If the operand is a memory location, its address is specified only by the HL register, then only we can call it as a M register. DCR B or DCR M, this is for memory related, this for register related. So, B value is reduced by 1 and stored in the same register. B value is 28, then 28 minus 1, which is 27. So, this for using decrement the counter value, we are using this instruction. Another one is DCX OR, that is RP register pair. The content of the register pair is decreased or decremented by 1, the result is stored in the same register. DCX H. So, this is a HL register pair. So, HL register pair value was 4555. So, after executing this instruction, this value is reduced by 1, it become 4554. Only the LSB value is or the lower register L value is reduced by 1. In today's session, we have discussed about data transfer instruction and arithmetic instructions. In data transfer instruction, we have seen the instruction format of transfer the data between registers, transfer data between memory and register, how to initialize and how to store the data. In arithmetic instructions, we have discussed about the addition and subtraction with carry and without carry, and also including the increment and decrement the register or memory content. Questions: which register pair content is called as M register? Give the format to add 16-bit data. Which instruction used to read data from memory? Which instruction used to write data into peripherals? Thank you.